Okay. Yeah, we had 2.4, 2.5 last time. We said what's wrong. We said those are different numbers. That makes no sense. You're not smaller nuggets in the meal. Here's how significant digits changes the language you're about to use. If you do a lab and you write 2.4, and then the next measurement's 2.5 and 2.5, and then you tell me in your lab these numbers are different, so the material's not the same. What's going to happen to you is this. I'm going to get out my sharpest red pen. I'm going to search for it in the bottom drawer where I keep my sharpest red pens. I'm going to pick it up in my fist like this. I'm going to slam it on your paper. I'm going to pull it across your paper because there's a little accordion things that happen when you pull your paper. That's what's going to happen to your paper. Why? Sorry, significant digits. And what does that tell us when I got 2.4, 2.5, 2.5? What's true about the last digit? It's sketchy. It's an estimate. We know it can be off by 1 because our equipment only allowed us to measure it so closely, correct? Which means 2.4 could have just as easily been what? 2.5, which means these numbers are the same. Not only do you have to say they're the same, but you have to then say to the degree, these are the same, therefore I've proven that these materials are all the same. From this ready, it says 2.4, 2.5, 2.5. I can't say those numbers are the same. My math teacher would laugh at me and throw me out of the room. Okay, you can try this. To the degree my equipment can measure it, they are the same. You can say that. Okay? But if not, you can just simply go with, those are the same. Okay? Because you know that last digit can easily be off by 1. You can kind of go, maybe it can be off by 2. You say if that last digit gets off by 3, you should go, that's when you start feeling comfortable. Okay? Does that make sense? Does it make sense? Okay. So if I give you a lab, if I get a lab report back from you, and it has 1.407, 1.408, and 1.409, same or different? Same, because all of them could be 1.408 to the degree I measured it. Okay? If I give you, the next one is 1.411, now you got a problem on your hands. That's 3 off. Now you have to sit and think about the lab and start to interpret your own thing. If I get 702.66, is that the same? Last name? Hillman. I want to say Hillman. I was getting so I got one name now. Is that the same? No, it's not the same. Clearly it's wrong. Clearly these are not the same materials. Clearly I don't have to answer that question even. That make sense? So as you interpret a lab, you could say the top three you have to say are the same. If I give you 1.411, then you're in that little bad zone where you have to say, yeah, gosh, 3 are exactly the same, and one of them's kind of a little off. I'm thinking those are all the same. I'm going to go with the same. Or you could argue, that one's off. Don't like it. Trial number 4 suggests they're not the same thing. But if you say this is the same thing, again, the red pen of death will land on your paper. Right? You don't want it. Jansen, do you think I have a real red pen of death?
Yes.
Oh. Good on you. Good on you. Good on you. I don't know if I do your dark. I go in that little drawer and look. Last year was an orange pen of death. All right, with that in mind and knowing what's at stake, tell me the length of that screw. Let's assume you can actually see the little dashed line. The dashed line is somehow, your eyeball can somehow pick up that dashed line, which is kind of weird, because that wouldn't normally happen in a measurement. But let's see if you can do that. Tell me what you'd write down for measurement for that. Write it down. couple of you struggle with rulers. That's interesting. Was not ready for that.
So 0?
No. No, there's a couple people that have like just didn't write down the right one at all. Not significant. They just worry about it. All right, here we go. Who wants to share their number? Because I've now seen all the numbers, so I got to make sure I don't cheat and pick somebody who's got the right answer, somebody's got the wrong answer, because that won't be. Ready, like, yes, sir. 5.12 centimeters. So let's see if the person sent his firstborn child off to someplace horrible. The Caribbean clan's going to lose their firstborn grandson. All right, here we go. Does everybody in this room agree that there's a 5 involved in this measurement? Yeah, I walked around, everybody had a 5. The next digit's a little bit interesting. 1. Does everybody agree there's a 1? Yes, there's 10 dashes. It's after the first one, so we'd say 5.1. Right, because it's 1 dash on the way to 10. There's about 3 of you that had 5.2 there. When you count, it goes up 10 dashes. If it's the first one, we do 1. Okay, so everybody agree on that? You're willing to swear on your baby, that's okay. All right. Which means I still have to estimate one more digit for those of you who stopped at 5.1. I do have to estimate the next digit. He said 2. I don't have a problem with 2. So in the back had 5.11. Would that be okay? That's totally fine. Okay? You said 5.17. That's not good. Is it 5.10? I saw somebody say that. That's fine. But that's just like 5.1. No, it's not, because you're estimating the last digit. You're allowed to do that, right? Everybody understand? You with me? Can everybody now understand why 5.12, 5.11, 5.10 are all happy places? And 5.1 is not okay. And 5.2, I don't know how to say that, but you need to learn how to use a ruler or whoever you people are. Fortunately, several of you, so I don't get to pick on this one person and use rulers with them. Okay, good? Okay, now the next thing we're going to run into is we're going to have to measure some liquids. To measure liquid, we're going to look at the side of what's called a graduated cylinder. Here's a graduated cylinder. When you look at a graduated cylinder, you try to figure out how much water there is. There's nice numbers on the side, so how can this be hard? Well, first of all, this is chemistry class. If you get it wrong, bad things happen. So we're going to be more careful than just, it's about 20. No, we're going to do a little bit of that. Yes, sir?
Water bows.
Water bows. And we're going to talk about that in just a second, but let me set it up before you finish that sentence. Before you finish that thought. So if I have a graduated cylinder that looks something like this, if you were to look at the side, you would notice the following. It's all fuzzy. The top is fuzzy. You may not have noticed this before, but the top of water is always fuzzy. Now he said this because water bows. Explain that idea.
Like it would rather grab onto the sides than it would like be in the middle, so it like attracts to the sides or bows down in the middle.
If you cut and open, if you're able to look inside without having to go through the glass on the outside, it would look like that. Agreed? If it looks like that because water is sticky. It's incredibly sticky. I saw the look on your face. You don't think water's sticky? Okay. You think water's sticky? How's water sticky then? Have you ever taken a shower? Okay. If you take a shower or bath, when you get out of the shower, what is stuck to your body? It's sticky. If you want to get it off of you, you can't shake. Well, a dog tries to shake it somehow. If you're mostly shaking, doesn't work, does it? What do you got to do to get it off you? You find a towel, which is good at picking up sticky things. You want proof? Take some molasses, put a towel in there. You'll never get the molasses out of there. Make sure your parents give you permission before you do that. You'll never, never. And you use that on your body, and suddenly the water's gone because it's stuck to something else. You get dirt on your body. You want it off. What do?
You want the water off.
You get some water, it sticks to the dirt, goes down the drain, no more dirt. Water is incredibly sticky. That's its best property. Well, that's not the best property, but it's one of the best properties. So it's sticky. And they're like, oh no, it's the opposite of sticky. No, actually, it's very sticky. Which means it always bows. If it bows, uh-oh, I lost my timer. How did I lose my timer? That's good. All right, good. So since it bows, the water always looks like this. Now, it sticks to the side very well. Actually, one more proof. Water comes in drops. Why does it come in drops? Sticks against itself rather than falling apart. It's that kind of sticky. Yeah. If it sticks to the walls, but most of it's in the middle, where do we go when we go to measure using a regular cylinder? Do we measure the top of the fuzzy spot or the bottom of the fuzzy spot? The bottom one. So you're more accurate if you measure the bottom. So when you go to measure them, you're always going to measure the bottom, what we call the meniscus. The official word for the fuzzy part. Okay? So you measure the bottom meniscus. So with that in mind, and knowing what you know about significant digits and struggling to measure things with devices, let's take a look at A, or number 1. Try number 1 right now. I'm not going to draw it with a nice curve because I'm too lazy to do so. So your water level, which I guess I'll use the color orange for or something random like that. We'll go green water. Looks like that-ish. Are we in agreement? That's a proper representation except for it's not curving up the side walls. So what was the answer some people have? What? 1.19. So man went with 1.10. 10.19. Okay. All right, what do you got? 12.50? Uh-oh. What else we got? Yes. 12. What do you got? Let's go. What do you got? 12.1. All right, this is a pretty good arrangement of possibilities. So first of all, I want to point this out when you talk about measuring. This is 10. This is 20. There's 5 dashes in between the two. Each one of those counts as 2, which makes this 12. So 10.19. 12 is the bottom of that, right? Okay, second thing. What do I get to argue? Are we all willing to say it's 12 exactly? No. Those of you who are like, this counts by 2, that makes me very uncomfortable. I would like to sit down with 12. I have to say, that's fair. I'll let you have it. On the other hand, I also look at this and say it's very close to 12. I feel really comfortable with 12. So if I wanted to go one more digit, that would be fine. So 12.1 would be fine. Who's my 12.50? Where's your baby going, man? That means you are for sure it's 12.5. Are you certain to be willing to take your child to Russia to spend time in a gulag making small socks for other people? Are you willing to go there? Yeah? All right, so then you're going to back it up. Now, 12.5 I'm not sure is a great measurement because I don't think it's halfway between a quarter of the way up on the next cell, but that's okay. We're measuring the bottom, right? So I would say it's closer to 12.1, but 12.5 would be okay.